There we go. I think we got technical difficulties solved. I'm glad we actually restarted. That would have taken a lot longer trying to do the other way. So I'm hoping that will be of help to us. Lindsay coming in with the first question on this one, and then we're gonna hit as many questions as we possibly can. I'm just gonna be bouncing back and forth. And Lindsay, I think that's a really good one. So let's hit this one, and then we can go over any other questions that you have here, okay? So let's go through these. I'm going to flip the screen here. Let's get this done. Let's go. Hey, let's really bear down. Oh, man, I really had missed y'all, by the way. I'm just pumped up about this this exam. Just doing your best. That's all anyone really could expect there. Go after it, attack it. All right, part D. Suppose that, and this is the one from Lindsay, she just wanted part D, but she said, now suppose the two blood bank specimens are selected at random. Make sure up here. That two blood bank specimens are selected at random. Find the probability that at least one of the specimens contains type A blood from the white ethnic group. Okay, so, let's talk about this. At least one, okay? If I go if I choose, and I've got gummy bears right here, these Haribo gummy bears right in my possession. If I chose 3 of these at random, and I say, what is the probability that at least one of them is red? Really what we're saying, the counter of at least one is 1 minus the probability of none, right? Because if you think about it, the probability of none happening would be that I would have no red gummy bears, right? But at least one means that I could have 1, I could have 2, I could have 3. It really is everything but the probability of none occurring. So when we think of at least 1, think of this as equal to 1 minus the probability of none happening. So really what we're saying is, when it says that at least one of them contains type A blood from the white ethnic group, it's really 1 minus the probability that none of them are type A blood and from the white ethnic group, okay? Ethnic group. So what would be the probability that none of them would be? Well, take a look at it real quick because that's really what we're focused on. Remember, 2 are chosen at random, 2 blood bank specimens. So 2 out of this are chosen at random. So it's not just 1. We're talking 2 different events, right? This is going to actually be the same probability. So what is the probability that this first one would have type A blood in white ethnic group? So type A blood in white ethnic group would be here, right? So it'd be 50,008 over this would be what it would be there, right? Would be where it would be white and A. But if it would be not, it'd be 145,057 minus 50,008. So let's do this real quick. Sorry for all my text messages here. We'll go 145,057 minus 50,008. We get 95,049 is what we got here. So 94, hold up, let me make sure. 95,049, my fault. 95,049 over my total, right? Which is 145,057. 145,057. Now, again, this is a lot high numbers, but you're going to see that this is the probability that the first one would not be a type A and white from the white ethnic group. And the same thing here. Remember, they're 2 at random. So it's this and this, right? Where they're independent. So once we multiply these 2 and then subtract by 1, we'll get the probability that at least one of them would be from the type A blood and white ethnic group. So we're going to look at this here. And I'm just plugging this in. Boom, boom. 95,049 times, I'll just say squared, be good. And then divided by 145,057, like multiplied by itself there. I get over here, this is what I get. So I get 1 minus 0.429. So 1 minus that, sorry, 1 minus my answer there would be 0.571. And that would be the, I would say, a 57.1% chance, or a 0.571 proportion, that out of the two randomly selected specimens, that at least one of them would be a type A and white, like a type A blood type and white ethnicity. And so that's how we would attack that in part D. It's a great question as far as at least one. How do you attack that? That's a really, really good question on that one. Good stuff. Okay. I don't see other questions, but what I'm going to do is I'm going to keep going back to it. So make sure if you do have any questions on this, keep posting on them. And if there are any issues, or if there's things that you really want me to hit on, or if there's technical difficulties or whatever, please let me know and we'll go back to it. The one I did want to hit on was this idea of a box and whisker. I think it was both on the multiple choice and FRQ section. FRQs, there are 3 to 4 on the test, and then multiple choice, there are about 20 to 25. So just as a heads up there. So it's almost like 2 tests you could expect that will be combined together from the throughout the semester. Now, the good news is we've been reviewing. It's not something that we've just been kind of going piece by piece. That's why we've been reviewing. So I feel confident about it, as long as we review and just kind of touch base on that concept list that's there, okay? All right, so let's take a look at this one, and then Lindsay, we will get to your one here. It says, write a few sentences comparing the distributions of seed mass for the 2 groups of plants. Now, when I go through each of these, for sake of time, I may not hit on every single one of them, but just as a heads up, I'll kind of show you what the framework would be. The first thing I would want to make sure of is to discuss context. So, for instance, if I'm talking about the cicada plants versus the control plants in terms of the seed mass for each of those, right? We could then say, and then we go into, and when we talk about this, we go straight into SOCs. Now, when I do this, I want this to be in complete sentences. I understand that right now I'm not going to probably write every sentence so I could get to more problems, but this is important to understand in terms of the FRQ section in writing in complete sentences and in context. So the first one, being the S, talks about my shape, okay? Now, the first one, since the median, you'll see, is kind of right in the center, this would be an approximately normal shape for the cicada plant, whereas this control group has the median more towards the right-hand side, making this skewed left. So we would say for the cicada plants, if we're writing something that's of a comparison, and I'll start with this first sentence, I would say context, right? We would say the cicada plant has an approximately normal shape. Remember LY words, right? To soften it, approximately normal shape, while the control plant is slightly skewed, and it's really probably not slightly, but we'll just say slightly skewed left. So this allows me to show both comparison, and it also highlights the S for the shape. As far as outliers go, outliers within a box plot can be seen by these stars that are either on the left or on the right-hand side. Those mean that those are outliers within our context. So actually here we would have no outliers because there are no stars here. Something important to recognize is our outlier formula is 1.5. Oh man, did I just mess up? Try to Yeah, I'm sorry. Wow, that was weird. Q1 minus 1.5 times IQR. That is my left-hand side, so anything to the left hand of this would be an outlier. And Q3 plus 1.5 times IQR is my right-hand boundary. So anything that's outside of this range from the low to the high would be an outlier if it's to the left and an outlier if it's to the right. But that's something you want to put this to memory. This is not on my formula sheet. That's here. So just a reminder on that. Finally, my center, you'll see my median right here, because that's our median, right? The 50th percentile is approximately the same. So I would say for cicada plants and control plants, the median is approximately the same, around 0.25 milligrams. That would be really good to put that number as well if I've got that. And then my spread, I would say, overall, the spread of the data is, I would say it's approximately the same. I would say that cicada plants is slightly larger as far as my spread for my range. My IQR you could use for your spread as well. Here's my IQR from here to here. Whereas here, yeah, I would say it's, if you used IQR, I would say the bottom one, the control plants, is slightly larger. So just be sure, don't just say the spread is larger for this one. Like, talk about what you would address. So like if you go ahead towards the range, that's fine. If you go ahead towards IQR, it's fine. You don't know what the standard deviation of this is, so I can't address that. But that's something that you can do when going through part A. Part B, based on the graph of the goal displays, which distribution has the larger mean? Okay, so remember, these are our medians, so be very careful. My mean is probably going to be pretty close to my median in this first one because it's approximately normal. And we know that median equals median, mean equals median, sorry, when it is approximately normal. However, when it is skewed, we usually use the median for center, right? Because it's resistant to outliers. That's something good too. So median is resistant to those outliers or to the skewedness of the graph, right? Outliers or skew. So we use that measure of center for skewed data. So we would say the mean actually gets pulled by these values that are to the left. So where the median would be here, right here, the mean, and I'll put my mu here, would be to the left side. I don't know if it's here or to the left, but it'd be towards the left-hand side. And you would justify this because on the top, the mean will approximately be similar to the median, right? So this is the first one. And then talk about the second one, how since it's skewed to the left, the mean will be pulled by the skewed graph or the skewed shape, therefore being lower than the mean the cicada plant. You could say that a bunch of different ways, but that's a good way of putting it, okay? Letter C, explain the purpose of the random assignment in this study. Remember, address this, that one cannot show, and you might want to put a little something extra in this, but one cannot show cause and effect, a cause and effect relationship, without random assignment. So what this does, and I would even go back up to towards the top, what is it addressing? It's addressing, so the response is the size of the seed, depending upon the cicada plant and the control plant. Let me say that 39 randomly selected plants. So 10 dead cicadas and then obviously some that did not. So random assignment allows me to show the cause and effect of whether the cicadas in those plants affect the seed growth, right? So it could show cause and effect when we randomly assign. If we're simply observing, remember that's correlation. One cannot show cause and effect with simple observational study. You have to randomly assign them to specific groups to be able to show that cause and effect relationship. That this the cicada plants or whatever we're talking about causes something else. Name one benefit and one drawback of only using American bellflowers in the study. The one benefit would be the fact that you don't have confounding variables, that when you only have one plant, you can say with more certainty that if there's a positive implication of cicadas on plant size or seed growth, then in that instance, you could say that because it eliminates confounding variables when you minimize the types of flowers. However, what your cause and effect relationship, this is the negative. The drawback is that the cause and effect relationship can only extend to that specific flower. So if we did roses, we couldn't be certain that the cicadas would positively impact those like it did the American bellflowers. So just making sure you discuss one of those issues. That what I just said was just an example of what it could be there. Okay. I wanted to go over this one though, because I know that this one was definitely one that people had some questions on. And then also was one that is going to be heavy on the fall exam here. Okay. All right, let's look at some other questions. I know that Lindsay had a question here. It's question 19. Let me see which one. The cumulative test, I think it's part 2. All right, yeah, it's a really, really good one. Question 19, and I want to get to this one, and I'm going to actually pull this up myself. So if you want to kind of come here, let's see. Flip chart. Let's do this. Pull this one up. I got a lot of them on here. Some of those ones that were later, I did not. So let me get this one on here. If you do have more questions, throw them out there as you're doing them. I hope this will be of help. Okay, so gotcha. So we've got Eric's in the house, by the way. Eric, welcome. Welcome, man. Hope the yeast is rising for you. Yes. Man, I have to throw the puns out there, y'all. You know what I'm saying? I know some of you hate it, but you love it at the same time. You know what I mean? Like, you hate it. Sorry, I'm doing kind of two things at once here. Pulling that up. Well, this comes up too. I'll pull up number 19 for Lindsay. Perfect. Had to close everything out earlier, but I think we are good to go now. Question 19. Yeah, this one's a difficult one, I'll be honest. It's tough. Let's check this one out and put it on this here. Perfect. And Eric, I'll get right straight to yours, okay? All right, hey, great one right here. I think that when I look back at the chapter, chapter 7 test, I actually was not displeased with it. I think that this was one of the things we probably could have hit on a little bit better from chapter 6 to 7. And we'll do that as we come back second semester. When people order books from a popular online source, they are shipped in a standard size box. Suppose the mean weight of the box is 1.5 pounds with the standard deviations of 0.3. So again, I like to take notes. We have a box here with a mean of 1.5 and a standard deviation. We'll call this X just because it's the box. Be the first one is 0.3. It then goes on to say the mean weight of the packing materials is 0.5 and the standard deviation is 0.1. So packing materials, we'll call this Y. The mean is 0.3. Hold up. I'm sorry. Mean is 0.5. My apology. 0.5 and the standard deviation being 0.1. And then the book shipped is 12. Wow, good night. The book is, we'll call this Z, just make that up, has a mean of 12 pounds and a standard deviation of 3. Okay. Assuming that the weights are independent, okay, so I'm guessing we're trying to get all 3 of these things together to make one shipment, right? Okay. It's like we put them all together. It says, what is the standard deviation of the total weight of the boxes that are shipped from this source? Well, let's talk about mean real quick because I think it's a good one. When we talk about mean would be the mu of X plus the mu of Y, like we're just adding them all together, right? And when we would do that, I'm not saying this is this, right? Because we're not talking about mean. But in this context, it would end up being 14 would be the total pounds for our mean, because we just add these three together. But we're not talking about mean. We're talking about standard deviation. And one cannot simply add standard deviation. I know you just did the symbol just like I did. Rocking. So when we add these together, we can't simply add these. So we have to take the square root of the squared versions of these added together. So it's the square root of x plus the square root of y plus the square root of z. I know normally we only do 2, but 3 is appropriate. We just add them all together after we square it. We take the square root and we're good to go. So 1.5 squared would be 2.2. Oh, no. Hold up. Got to get my calculator out. My fault. So we're going to go there. Go on the magical journey with Coach Jay through the calculator. No, hold up. My fault. My fault. This was my bad. 0.3 squared, right, would be 0.09. Might be 0.1 squared would be 0.01. I was looking at the mean. 3 squared would be 9. Okay? So we got all of these together. So we've got 9.10. And then we take the square root of it. So let's do square root of 9.10. I hope I did that in my head right. Square root 9.10. If you hear my son, I apologize. We got right here approximately 3.02 as my standard deviation, and that would be what C would be equal to. Lindsay, I hope that makes sense to you when you look at it. The big thing, I always try to dissect, okay, what are they asking me? What have they given me? And then what are they ultimately asking for within that question? When I take notes off to the side, it just always helps me. Sometimes that may or may not, depending upon the question. But I hope that helped you out a little bit, Lindsay. Great question. All right, Eric, I'm right here with you. I'm looking and seeing any other. All right, money. Yeah, gotcha. Eric, I am coming. I am coming for your question. Let's see where you're at there. Oh, sweet. Okay. Yes. Rar. Okay. Why would there be 2? Wouldn't it be? Oh, man. Okay. Gotcha. My apologies, y'all. I was kind of going back and forth. Yeah. Sorry about that, y'all. Good. Lindsay, you're good. Eric, good. Charles is here. Yeah, then it's good. He's a little fussy. I told him he needs to grow up a little bit. That's what I told him. I said, you need to grow up. Stop being a baby and grow up a little bit. Eric, your question. Let's see here. All right, Eric, I think I addressed your question. Correct me if I'm wrong. I'm putting something on here. If I did not, please let me know. I think Lindsay actually answered that great there. I think she did great. While I keep going back and forth between the different posts people are putting here, I do want to take this time just to hit on a couple of things. Oh, you know what else I needed to put right here? I just wanted to put really quick was this. This is our concept list. I know it looks like it's a lot, and it is, but I hope this allows you to kind of funnel your attention down to specific areas that you may have questions on. So even while I'm going through some of these things, feel free to pause this, go over it, review it. I'll be honest, I don't know why people ignore this. This is huge, okay? So when I say things like, and I'm just throwing something out there, when I say what is the double blind definition, understanding that, oh yeah, double blind, what does that mean? Double blind means the person administering the test is blind as well as the subject. Okay, I just wanted to put that down there just so you could see it. So if I'm administering the test, I don't know what they are getting, whether someone's getting a placebo or not. And then the person that is actually consuming or taking that, maybe it's a vitamin C pill versus a placebo, they are unaware of whether they're getting the placebo or not. So that would be a double blind definition. Single blind is where if I'm administering it, I know, but the person getting it doesn't know. But double blind means both parties are unaware, and that allows us to eliminate bias of maybe giving a hint to that individual, trying to get, specific results from them or something, whatever it may be. So that's what we're trying to look at and look into. That was there. Okay. All right. Perfect. I just want to make sure I'm pulling this up. Concept or something says it's Ask Coach Jay. Oh, yeah. My fault. Yeah. That was a good one. Number 2, using probabilities in a real world situation, finding the expected cost. Remember chapter 6. Okay. Y'all are on the podcast. You ready? I'm going to actually give it to you right now. I'm literally going to give this to you because I feel nice today. I feel like I'm in not the Christmas spirit, because that would put me in a bad mood, but I'm joking. I like Christmas. I do. I'm actually pulling up the exam now. That'd be bad if the exam came up on my screen. That'd be, I'm sure you would be happy. Everybody would be happy on that one. And then Lindsay, yes, I'll get to number 24 as I go through. I wanted to just go over with you real quick. Do you remember on the first FRQ on chapter 6 test, it was people either did awesome on it or they did awful on it. And the question revolved around this idea of finding the expected number of repairs for 2 different printers. And if you remember that might be something just to pull up in your mind as you're looking at. I would actually study that problem. That would be a really good idea for you to do right there. I'm trying to actually go through it. Make it sure. I'm actually just making sure here. I'm just making sure I read it just so that I can kind of direct where you're going here. Okay, so with this one is one where it's going to give you 2 specific antibiotics. And the goal of this is to be able to figure out which one would be the best option. It is very similar to the expected cost, mainly because there's kind of 2 different scenarios that it gives to you. And what you've got to do is be able to say, it really is using probability in a common sense way. So it's either this or this happening. And what you're trying to do is compare the different options, very similar to the way that you did the printers in that way. And what you're trying to do is show which plan would be the most beneficial. So it might say, I'm trying to do it without. Sorry, y'all. I'm trying to think without actually giving it to you, but yet helping you a lot. Okay, let me do this. Let me take a quick pause because I think this will be good. I'm just trying to think through what would be the best, but I'm just going to go straight into it. Okay. I'm just going to go over an option, okay? One thing that I get a lot is migraines, okay? So, and I'm going to use this as the context here. I'm just going to go over one different situation, okay? Couple of plans that I have. I'll just go over one plan. One of my plans that I have is I usually start, and this is actually a real thing. I'll start if I have a migraine, right? So Coach Jay's got a migraine here, okay? All right, here he is. He's got a migraine. There's two different things that I kind of approach. First of all, I try to like see, can I drink a Coke, right? And then if that works, then obviously I stop. But then also then I can go to Excedrin. All right, this is actually, I can't believe I'm giving you this hint. This is good. Let's say the Coke works 40% of the time. Excedrin works about 70% of the time. What is the probability that Coach Jay will be cured? Again, I start with this and then I go to this one. So really what I would do is draw a diagram. Really, that's kind of how I would approach it, where my migraine has the capability. First of all, I give it Coke, right? Okay, I get Coke. As I get Coke, I have two options. I'm healed or I'm not healed, right? If I'm healed, I'm done. The probability of being healed in this instance would be 0.4, right? The probability of not being healed would be 0.6. I'd be not healed. So then if I'm not healed, I go to another option, which would be Excedrin, where I have an option of either being healed or not healed again, right? So this would be like the Excedrin option, right? So this is Excedrin going in, right? And so I could either be healed or I could be not healed. The probability that I would be healed in this instance would be 0.7, right? So I'm going to circle these real quick. The probability of not being healed would be 0.3. So very similar to a tree diagram. My question is if I follow this plan of action, what is the probability Coach Jay will be healed? This is such a good illustration, okay? I'm telling you right now. Probability of being healed, all right? So as I look at this, the probability that I would be healed in this example would be 0.4. And then I would have to, because I have multiple things happening here, of 0.6 and 0.7, this would actually be 0.42 being healed. So because it's this and this, right? Remember tree diagram? And then 0.6 times 0.8 is 0.18. So the probability that I would be healed would be 0.4 plus 0.42, which would be a total of 0.82. Or I could just simply say 1 minus not being healed, which is the only one over on this side. 1 minus 0.18, there you go. So my probability of being healed is 0.82. So using that to be able to attack this plan is just, it's using common sense with probability to be able to attack it. And that's a good example of what I'm trying to look at there, okay? I can't give you any real more information. I gave you a ton. But that is one thing that I wanted to make sure I went over as far as question to the second FRQ here, okay? And it looks like I did give the fact that you have 3 FRQs, all right? And I went through each one of them, which is nice there, okay? All right, number 24, it's a tough one, combining 2 normal distributions, then finding a new normal distribution, and then finding the probability. Lindsay, do you remember this one here, okay? So this is a very interesting question because this is, you're actually finding the standard deviation of this, right? And the mean if I ask for it, right? So the mean of this would be 14 pounds, right? And the standard deviation would be 3.02. But let's just say that in each of these instances that this box was chosen at random, the packing materials were chosen at random, the book was chosen at random, but the mean expected value, the standard deviation followed this suit, okay? So a little bit different scenario because this is hard and fast, 14, 3.02, right? Based upon what was given here. But let's just say that out of this whole thing, we want to ask, what is the probability? What is the probability that a total package would weigh more than 20 pounds, okay? All right, so first off, what we've got to do is be able to break it down like we did to have 1 part, 2 parts, and 3 parts, right? And our goal is to combine all of these together, just like we did below, to find the 14 as our new mean and our 3.02 as our new standard deviation. That's very important. So maybe there's not going to be 3 of these. I think there's actually 2 of them, 2 sets of them. But you could do it with 2 or you could do it with 3, understanding how to combine the means and standard deviation to find their new values. So what you've got now, let's say that it states in the problem that it is approximately normal, okay? I'm making this as I go, but approximately normal. So what we can do with this to find what's the probability of it being over 20 pounds, we can actually draw a new standard deviation. Now, if each of these are normal, and in this case, we're just assuming that they are, when we combine it, we'll have a new combined normal distribution that comes not from these 3 individually, but the combined version of the mean and standard deviation, where the mean would be 14 and the standard deviation 3.02. So as I look at this, 14 is our mean, 3.02 is our standard deviation. My highlighted area would be anything that would be at 20, and I'll just put 20 over here, or greater, right? Now, a couple things people did that are a no-no. Never use normal PDF. I saw this a lot on chapter 7 test. Anytime I use a normal distribution, I have to do CDF. I can't find just one value in a normal graph, right? Because it's the area of something. So I'm trying to find what this area is here. And to do that, I go to normal CDF. And if I was on an FRQ, I would have to show, like, write out the formula, lower, comma upper, comma mean, comma standard deviation. But my lower would be 20. My upper would be a high number. My mean would be 14, and my standard deviation 3.02. And so again, I'm making this up as I go because I wanted to give you an example problem. But this would be the area of it. So we go to second vars where our distribution is. Make sure you know your calculator stuff for the test. 20, 999, 14, 3.02. So this would be 0.0235. 0.0235. So I would say a 2.35% chance of it being 20 pounds or greater based upon the information that's been given here. Okay. I hope that makes sense. I kind of combined different things there, but I hope that that helped a little bit with where we were at. Now, I apologize. Let me see if I've got any other questions out here. I am not bashing Christmas, Charles. I am simply, I like Christmas. I like the feeling of Christmas. I do. I love hanging out with family. It's the commercialization. That's the only part that gets me there. All righty. Let's see here. Can y'all still see me? Okay, good. Yeah. Oh, Lindsay, I'm sorry about the Christmas spirit thing. I do like Christmas. I really do. But, okay, so kind of, no, I do. I do kind of. Okay, I do kind of. All right, let's go over other questions before people start yelling and throwing stuff at their computer. I would hate for that to happen. All right, Lindsay, I'm hearting those because, well, I got them there. Did I get your question? I think we're good there. Did I just like my own comment? I think I just liked my own comment. Can I do that? I think I can. That's good. Cool, cool. If you got any more questions, throw them out there. We're just kind of going over concept lists and just literally any questions that you have. I am free right now. I'm literally, I told my wife, I said, I'm going to be with AP Stats as long as they need me. So if you are with us right now and you're like, man, I got this question or something, I've got 6 viewers right now. And I'm looking at my screen. That looks really colorful, by the way. If you're looking at this right now, it's pretty impressive. It's good. Good stuff there. And I might be kind of behind. Might be kind of behind there. So yeah, those stuff out there. If you've got any other questions, I'm trying to think of any other things that may have come up. Lindsay's got a question. I think she does. Let's see if she does here. Drum roll, please. Question 12. Let's go. This one is off of, again, if you're following the cumulative practice here. let's see here. Back on this one. I think this is the first one. By the way, I hope these cumulative tests were just a little helpful, just to get reps in. Again, don't want to memorize the question, just want to know the processes, right? That's the big thing. Address the process and go from there. Cool. All righty, let's do this. All right, question 12. This was on cumulative test 1. So if you're following me, go right ahead. This one says a linear regression was performed using the 5 following data points. The residual for which of the 5 points has the largest absolute value? Yeah, okay. So first off, when we look at a residual by definition is something where it's the actual minus the predicted, right? So actual minus the predicted. And when we looked at this, this would be like y minus y hat, where y is the actual value and y hat is the predicted value. So each of these points are if you're talking about the y, they're the actual y's here. So if you look at this, like 222, 10, 5, 10, 4, should be like lower, right? 6, 14, 14, 2. I'm just going really low. I'm sorry. And then 18, negative 4. So it'd be like 18, negative 4. All right. So what we've got here is we've got something that is, and by the way, if I were to describe this, remember DOFs, right? Direction, negative. Outliers, talk about that. Form, linear, approximately linear, whatever. And strength is related to our correlation, right? So remember our correlation, not to be confused with residual, is related to a value of R, where the closer it is to 1 and negative 1, the tighter it is. Okay, I know I'm kind of throwing a lot out there, but that's the idea, just so you're aware. So if I were to take the residual of this point, the residual is the distance between the y, which is the actual point there, and the predicted, which is the y hat, which is the point on the line. So we're trying to find what this residual would be. Now, I do not think that this is on the actual AP exam in terms of finding this residual. What I will do is just quickly, hello, gentlemen and ladies, good to see y'all. I'm going to pull up my calculator real quick and show to you. While I am doing that, because it takes a second to be able to pull this up, you want to see a picture of my son? Yeah. Okay, so I apologize for this. I don't know what he was thinking. We're still trying to work on his facial expressions. But this is what yeah, this is what I got today. I was trying to teach him some AP statistics stuff, and this is just this is the face I got today. Gotta love it. Gotta love it. All right. Sweet. Oh man, did they? Okay. Well, my TI calculator is kaput. My apology there. Let me do this. Let me do this on my phone, and then I'm going to show you. Okay. I don't know why my TI calculator is messing up. That's okay. So if you go to your stat edit, okay. So like, let me see if I can do real quick. So if you go to stat and edit, oh man, that's awful, isn't it? I kind of can see it. You want to go to stat edit there. You see the stat button, and then you go to the edit, and you'll see it there. In the first list, that's where your where the L1s are. You're gonna put all your X's there. So all my X's would be 2, 10, 6, 14, and 18. And then on the Y side, you're going to go over there and you're going to put in 22, 4, 14, 2, and negative 4. Now on the L3 side, a lot of times if you go up to the L3, so I'm going to hopefully try this, okay? I'm going to kind of minimize this here. Okay, so right here, you'll notice that in the L3 side, that's better. I know it might be backwards, I'm not sure. But when you look at the L3 side, we're going to go right there, okay? All right, so you're going to go right straight to the top when you put X and Y's are in. And what you're going to do is you're going to go to Stat, Calc, okay? So you see this here. Sorry, right here. Okay, Stat, Calc, and then you're going to go down to Linear Regression. Okay, number 5 is on my list, okay? So you're going to go down to Linear Regression, Stat Calc, Linear Regression, and you'll just put L1 and L2 in, okay? So we're going to put L1 and then L2. Let's see if this will work. It's my different calculator. I believe this is what I got. I want to make sure. So you should find that this is your y equals ax plus b. Okay. Cool. All right. So then you're going to go to, and oh man, literally. Oh yeah. So then you're going to go down to Stat Calc. I don't think you have to do this on the test, but it's good just to know what a residual is and to know which is the furthest and all of that. So this is a good conversation. So go back to residual. Once you put in like, hey, what is y equals ax plus b from this? This is your linear regression, and these are where your points are. Go back to L3 up towards the top, okay? And then what you're going to do is you're going to go back to second stat, which is the list, okay? So go back to second stat, which is your list. You see right at the bottom, you see residual. You should have it there, okay? When you press residual and then go to enter, okay? So literally what I did was I put residual in right up here, okay? And then press enter, and then what it did is it compiled all of the residuals from over here. So let's talk about this real quick. Which has the largest residual? The largest residual is the absolute value of whatever the residuals are. A negative residual just simply means that my predicted was less than my actual, right? Does that make sense? So when we look at this, the 10,4 is the one that would be the residual that would have that it would create the greatest residual, if that makes sense there. Okay, so since it creates the greatest residual, we would say that predicted was furthest away from its actual, and so because of that, that would be the one that would I wouldn't say it's an outlier, but it would definitely be the one that would have the largest residual that's there. Okay, you would never have to do that by hand. More or less, if you're looking at your let's see here. I actually want to. Where are you? Okay, let's see here. I just want to show this. When you're looking at like a point or something, like knowing what a residual is, the definition, it's the actual minus the predicted. If I gave you a graph and I had like points here, right? And then I would say like, hey, what type of, would this be a positive or negative residual? Well, this would be the actual, the predicted would be down here, right? So actual minus predicted, this would be higher than this. So this would actually create a positive residual, whereas the ones that are lower would create a negative residual. The one that would have the largest residual would be the one that's furthest away from the least squared regression line, okay? And remember, what is least squared regression line? It is literally the line of best fit that minimizes the squared residual. That's it, minimizes the squared residual. Another thing that people need, well, you need to know is this idea of y hat equals ax plus b. So if I were to get the context of arm span explains height, okay? I don't know, I'm just making this up. So in this example, then we would say the arm span is my x and the part that it gets explaining is my y or y hat. So if I was to put this in context, and I'll put numbers in just for the heck of it, I would say my height is my predicted, and it equals, and I'll just say 3 times my arm span plus 0.25, okay? So if that was a least squared regression line that fit, right, this would have a positive slope, right? And right over here, so a couple things on this that I want to note. This right here is my y-intercept, okay? What that means is that as I look at my point here, the point would be 0, 0.25, meaning, like in basic algebra terms, that when x is 0, y is 0.25. Or when my height is 0, my fault. Back up. I messed up. I said that backwards. My apology. When my arm span is 0, because that's my x, right? This is like my x and this is my y hat. When my arm span is 0, the predicted height would be 0.25 inches, feet, whatever we're talking about, okay? So remember that. That's what we're talking about with y-intercept. Now, really important because I know this is on the exam, okay? When we talk about the slope is rise over run. Now, there is no run that's visual right now, but we know that this is like an imaginary 3 over 1, meaning as I rise 3, I run 1. Or as I increase by 3 on my y, I increase on my x by 1. Again, interpreting this, we would say that as my arm span increases by 1 whatever, I don't know, whatever the context is, it is predicted that my height will increase by 3. Again, feet, inches, whatever we're talking about. But when we talk about the rise over run, it's very important that you understand that the rise is my y, my run is my 1. Now, what if I had y hat equals 1/2 x? My rise would be 1. My run would be 2. Okay, so this would be on my x. This would be on my y. So as I run 2 on my x, or as I increase by 2 on my x, I increase my predicted value on my y, whatever we're talking about in the context of this problem, okay? Cool. I know that took a minute. I hope that helped a little bit there with that one, and kind of just went through a couple of different things as far as residuals and really hit on, I think that was chapter 2 or 3 there. So yeah, hope that was helpful for you. Alrighty, let's go through. Where's our review session? Nice. All right. Wow, Eric. Wow. Good night, Eric. Wow, good night. I just fell asleep. Eric, it's like 9:30, dude. Wow, am I really that boring? Yeah, I'll be honest. I'll be completely honest with you. This is one of my favorite times. I love doing these with y'all. I know that you feel the same. I really do. I know. I appreciate you for just giving me as much as you can, all right? Again, I hope that this is helpful. I'm just trying to go through as many questions as possible as we go through it together. So if you need to leave or want to come back or you want to pause it, or hey, you don't even have to watch this. That's fine. I'm just trying to do it for those that really, really need it there. Okay. Cool. Look at number 6. That looks very familiar, right? We just went through that one. Make sure of that. Area in a normal distribution. Anytime I see that, I think normal CDF. Remember, don't ever use normal PDF. Otherwise, I'll haunt you forever. Okay. Haunt your children's children. In fact, if anyone does normal PDF on this test, if they do, I will name my son standard deviation or sigma. No, I'll name my son Sigma. I'll rename him. All right, because technically he's not named yet, so he'll be Sigma. So don't do normal PDF, otherwise my son will be Sigma. All right, but yeah, check out a couple of these other things as you're going through it. I know, yeah, we went through 24 pretty good. I feel pretty good on that one. See if there's Lindsay posted another question here. This is good. Lindsay, keep them coming. Keep them coming there. I'm here for y'all. Let me help you. I hope that all my tangents on some of these problems are helpful and not too crazy. I'm just trying to go through specific questions that you have there. Thank you for putting them on here too, the actual question. That helps me. All right, we're going to go to number 9. This is on cumulative test 2, right here. It's cumulative test 2. Here it says, suppose that you have a torn tendon and are facing surgery or to repair. The orthopedic surgeon explains the risk to you. Infection occurs in 3%, and the repair fails in 14%. And both infection and failure occur together 1% of the time. Now, I think when I look at this, I've got infection, 3%, right? Failure is 14%, and both is 1%, okay? What is the probability that the operation is successful for someone who has an operation that is free from infection? Okay, so the idea of this is really we're saying, what is the probability? This is literally what we're finding. What is the probability that it is successful for someone who has an operation, successful for someone who has an operation that is free from infection? So what is the probability that is successful given that they are free from infection? Now, there's a couple things you can do here on this one. A couple of things that you could do. I would say, first off, that when we talk about this formula that we're addressing with something that's given, we remember that, and this is on your formula sheet, the probability of A and B is equal to the probability of A times the probability of B given that A occurred, right? Now, when I look at this, this is the formula that they're going to give me on the AP exam. Can I connect this to this up here? And I think I actually can. So if I were to say here, what is the probability of A, B, all this stuff, right? I'm trying to find what this is. So can't I just plug this in for what's up here? You say, Coach, what are you talking about? Well, let me do this. Maybe this will help. Get this by itself, okay? So if I divide by probability of A, okay? All right. By the way, the one thing with the given, I get confused with the given stuff. So yeah, I could go to like a Venn diagram. That would actually work, right? You could actually do Venn where 1%'s in the middle and, probability of infection minus this, like do the crescent moons and then the outside. You could have absolutely done that and been absolutely fine with it. For me, I think it just is a little easier on this one when we're talking about given. It's easier to solve. So if I did probability of A on the bottom and on the top is probability of A and B, this equals the probability of B given that A occurred, right? So what is the probability of B given that A occurred? The probability of success given that they're free from infection, okay? So if I was to do this real quick, the free from infection part, so this is this, right? So this would be the probability of A and B. What are the probability both of these occur? And that is 0.01, okay? The probability that A occurs, or the probability that they are free from infection, would be okay, so this, hold up just a second. I think I just messed up here because I did it backwards. So the probability that they're both, right? So A and B in this instance is that it's successful and free from infection. These up here are like the complements of these. So they're the counters of these. So if this is infection, not infection would be 97%, right? Not failure, this one almost got me on this one. This would be 86%. And Just making sure. My apology real quick. Probability that they are successful, given that they are free from infection. Real quick, my apology. I was looking at this for a second and then just totally blanked. I like where I'm going with this. Hold on tight. The only reason why I say just question mark is I'm still solving for this, right? This connects with this because I matched up what I was doing here. Probability of B given A, probability it's successful given that they are free from infection. This probability of A is the probability that it's the second one that we are free from infection, which would be 97%. So that's 0.97, okay? So as I look at this, if that's 0.97, what is the probability of A and B occurring? Well, when I look at this, A and B would be where it's successful and free from infection. And I just want to check this real quick. The middle would be 0.1, right? Outside on the left, we'll just say this is infection. This is failure, okay? So this would be like what we're talking about with this left side and right side. The fact that they would have an infection, this would be, yes, an infection, would be 0.03. So this is actually 0.01 in here. So 0.03 would be here. So that means just an infection would be 0.02 because I have to subtract it because that has to combine to equal 0.03 or 3%. So same thing over here. If this is 14%, this would be 0.13. So what's anything on the outside? That would be 0.02 plus 0.01 plus 0.13, which is 0.16, I believe. So that means 0.84 would be anything that would be successful, right? Or not infection and not a failure. So that'd be 0.84, anything on the outside here. So this would be 0.84 divided by 0.97. 0.84 divided by 0.97. Get 0.865. 0.865 or 0.866, okay? As I explained it, I'm trying to go through in my head how I would maybe do this a little easier. As a math teacher, I like formulas. I like to approach it in that way. For some of you, if that confused you, just trying to give it to you in an easier way, I would start off by writing this up here. I think the green stuff that I put here and even the white right here is something that would be beneficial. I would say the part that makes it difficult, the part that makes it a little strange as far as the formula goes, is the fact that you have something, the probability of something given that this occurred. Usually I wouldn't even go to the formulas in teaching this. I would go straight to the Venn diagram. If I said, what's the probability that both will be successful, I'd go right straight here and go to 0.84. But because of the fact that we have this given, I would go to this formula. I would write it out and I would just say, okay, this is what I'm finding. This is the given that I'm finding. This is the given I've got to isolate, right? And we did that by finding the probability of B given A, right? By moving it over from the formula off the AP exam. And when I divide it, probability of A, as I match it up right here, is the one that's free from infection. We said that was 0.97. I felt like we were pretty good there. This one, it just took a little bit of kind of probing and using the Venn diagram to identify, oh, this is the probability that you would not have an infection and not have failure, or that both would be successful. That's probability of A and B. That's a tough one. I think that that's a tricky one there. I'm trying to think, is there another way that I can't think of anything else. Maybe a tree diagram. That might be good too, a tree diagram as well. I could have maybe done that as well. But yeah, that would be the best I would say in terms of going after that, okay? Okay, so yeah, a little different, okay? So this is not an independent event, right? You say, Coach, why is that? Well, as I look at this, you'll notice that the formula of probability of A and B, let me actually back up in a second here. The probability of A and B equals probability of A times the probability of B given A. The fact that I used this part here allows me to see that probability of B is impacted by whatever happened in A. Does that make sense? So, like, for instance, if I said the probability of success and failure, or I'm sorry, probability of failure and infection is equal to the probability of failure times the probability of infection, then this would actually be an independent event. But notice this was not true, right? In fact, we showed that this wasn't true because we were trying to find what is the probability of success given that, what was it again? Probability of success given that they were free from infection, right? So you had to kind of work almost backwards a little bit, but you realize that the probability of success given that they're free from infection, I can't use this formula here. I've got to transform this formula because this is a dependent event. And you could just, based on practical knowledge, know that my probability of success will change given that someone's free from infection, right? It's pretty logical there, but you could also show that. So this turns into the probability of B given that A occurred. So it changes based upon whatever happened in this first probability of A. So the white one is exchanged for a dependent event, and then the one in orange right here is an independent event, right? Cool, cool, cool. I hope that made sense. I hope that made sense there, Lindsay. I felt like that was the first one that I went through that I was like, I hope that that wasn't too confusing. Oh yeah, and then also kind of below this, so this is the independence world, right? In a separate world, the probability of A and B is equal to 0. Well, what does that mean? That means that this is mutually exclusive. You can't think of these really as the same thing. Think of them as separate things. Mutually exclusive just simply means that these two events can't occur at the same time. At the same time. Now, we know that this following scenario up here was not mutually exclusive, but if it was mutually exclusive, that would mean that you would not be able to have both a failure and an infection. It's just an example. A real world example is what is the probability of getting a red card and what is the probability of getting a black card, where this might be A and this might be B. These are mutually exclusive events because you can't have both of them at the same time if I drew one card. And so since I can't have them both at the same time, we would say it's mutually exclusive. Okay? Cool, cool. I hope that made some sense there. That was a tough one. That's a really tough one. So if you get question 9, I think you're good. I think the big thing is that hey, what are they asking me? That whole given, like pulling that out of this problem, writing out what you know. To be honest, if I saw this probability one, I would save this for last for me, especially when I kind of tripped up on how I would explain it. I would wait for that one until the very end and then take my time through that one as I go. Or maybe do it really quick and then always come back to it because it does take some thinking and really finding the formula. And then also it's good to know where the formulas are. That's probably a good point to kind of just know where the formulas are and go through those. Okay, cool. Lindsay, I just saw your comment, by the way. Do not write normal PDF. We never use normal PDF. The only time you'll use PDF is binomial, and we use binomial PDF because remember, it is a discrete value, which is another really good point. I'll kind of just hold off right there. So if I were to get a discrete, right? Discrete would be a number like shoe size. It's a good example, right? I could have 10.5, I could have 11, I could have 11.5, and so on and so forth, right? In either direction. That's discrete. This would be something that's discrete. We use like binom, PDF, or CDF, depending on if it's that value or anything less than that value, or just that value. We can do that, right? So this is just one value, where this is value or any and anything less and anything less than. Okay. All right. Geometric. Okay. I'll just put geometric. PDF and CDF, same thing. But this is only for a discrete value, right? Where it has spaces. It has spaces between, right? But we remember that cumulative, so discrete versus cumulative values are values like a normal CDF that you can't say what's the probability of that one thing, right? Because you're talking in terms of cumulative, and this does not have gaps, right? So it's just continuous, right? And that's the word I was thinking of. It's continuous. It's a continuous graph. It's a normal graph. So when I do this, I can say the area between two values, right? Lower bound, upper bound, mean, standard deviation, or z-score, right? That's what we talk about, z-score. But a lot of times we're talking about area, or we're always talking about area within a cumulative. Another thing to remember too is our z-score is equal to value minus mean divided by standard deviation. Okay. Remember what this means. Z-score means the amount of, I hear you, Chloe, standard deviations above the mean. I think it was hers. I think it was Chloe's, but I could be off. From the mean. And then the standard deviation value is the average distance from the mean. Average distance from the mean. Okay? From the mean. And remember, we could have a positive or negative z-score. A negative z-score is to the left of my mean, and a positive z-score is to the right of my mean. Okay? Cool. Remember the empirical rule, 68, 95, 99.7. This means 1 SD to the left and right. This is 2 SDs to the left and to the right. And this is 3 SDs to the left and to the right. Okay? Cool, cool. All righty. Let's see if there's any other questions here. Man, I'm hitting on a lot. I don't want to keep us here if y'all don't have any other questions, but I also want to make sure that I do address any other questions you may have. I'm trying to go to my handy dandy. Let's see here. Oh, there you are. Yeah, this is good right here. Make sure you hit on them, right? You'll see those there. Probability distribution. Yeah, make sure we know those, right? Probability distribution. Binomial, geometric, and neither, when to use each. Bins and bits. Estimating standard deviation by looking at a graph, right? This one was one too. As we looked at it, this is unrelated to this problem. But if you were to have a normal graph right here, and this was like 10, and this is 20, like they give you these values right here, 0, and let's say -10, and so on and so forth. And your options are like, can it be the standard deviation be 2? Can it be 5? Can it be 20? Can it be 10? Can it be neither, right? Remember that like 2, we want to follow the 68, 95, 99.7. So as we look at this, we want to make sure that 3 standard deviations should cover most of it, right? In fact, it's 99.7% of the data to the left and to the right. So just be sure that in that instance, you that it's covered, right? That whatever one approximates it the best, and then just go with it from there. Cool. Alrighty, I'm gonna kind of give you about 30 more seconds if you've got any other ones here. And I actually got one more. 3 on this one. It's from the test. Let's see here. Ooh, yes. This one's good. Do that one. Cool. Lindsay, question for you. You can just write here if you're good. Are you good in finding the actual standard deviation? Like if I were to say, hey, what is the standard deviation for X and Y, right? Where we're talking about a probability distribution and you've got X and P of X, right? And you got your X values of 1, 3, and 6. I'm just giving this as an instance, right? And remember, our probability distribution has to be between 0 and 1 for each of these and have to combine to 1. And we say that this is 0.6, 0.3, and 0.1. We could find this standard deviation, right? So like the standard deviation of X, we would put this into L1, this into L2, and then one variable statistics, one var stats. And then we would put for frequency, we would put L2, right? Because the frequency would be my probabilities. I hope that makes sense. If it does, just throw a little note there. I'm going to assume that you were good on that because I think I did see. I'm going to say yes, you're good because this is 1.58, and then on the standard deviation of Y, you got 1.81. The question that this asked was, okay, good. The question that it asked was based upon this information, right, that you found, what was 4x minus 5y? Well, let's talk about this real quick. Let's do order of operations first by going to my 4x and 5y. When I go to 4x and 5y up here, can I multiply 4 times the standard deviation? And the answer is yes. The same holds true for multiplying 5 times 1.81. What I can't do is add 3 to it, right? Or add 2 to it. But what I can multiply. So when I go to 4 times 1.58, let me get rid of this real quick. We get 6.32, okay? And when I do 5 times 1.81, I get 9.05. So right now what I did was I just did it separate, but I multiplied by 5 and then multiplied by 4, 4 with X, 5 with Y, right? Now, if it was mean, we could just simply subtract them together, the X minus the Y, and we're good to go, G to G. But because this is standard deviation, everybody now, one cannot simply add standard deviations. So I've multiplied by 4 and 5. Now I've got to take the square root of these values squared. So we'll just say the new standard deviation of X squared, right? The 6.32 squared, okay? Plus the new standard deviation of Y squared, 9.05 squared. And then we add them together and there you are. So let's see if we can do this bad boy, 6.32 squared plus 9.05 squared. And then I just take the square root of this, and there we are. I got 11 point, make sure, 11.03, 11.05, yeah, there you are. So it'd be 11.05-ish, 11.03. And that's how we would find it, okay? Cool. Very good stuff, y'all. How many faithful few? Oh, there's 5 viewers out there. Oh, man, y'all are great. Y'all are absolutely great. I hope this was beneficial for you. I'm going to do this. Oh, yeah, great question. Oh, that's good. So remember that no matter whether you add or subtract, so with the 4x minus 5y, if I were to, if it was mean, you would do whatever it says. But with standard deviation, the adding or subtracting has no impact when you're combining them together. It is always this formula when you combine by adding or subtracting standard deviations together, right? Right? So whether I add or subtract, it's always this formula. Another thing to remember too is if I took this standard deviation and subtract by 3, it would just be the same thing, right? So we're talking this formula only when I'm combining standard deviations together by either adding or subtracting. Great question. Great question. I'm going to heart those because those are good. Cool and cool. Awesome. All right, I did hit those. Again, as you're preparing, I appreciate the fact that you're on here. Show a ton of work because, again, that's going to be huge there. Nice. I'm just making sure. Observational. Remember, experimental is showing cause and effect. That's random assignment. Observational is where I'm just simply observing what's going on. I can't have cause and effect. I can say correlation. This correlates with this, but I can't say this causes this in an observational study, okay? All righty. I'm just hitting some high notes. STEM plot, make sure you know how to do a STEM plot. Different types of bias, go through that. What are the different types? How do you remember the different types? Remember, median is the 50th percentile. Yeah. Remember, whoever did better using z-scores, make sure you know how to do that, and you'll be golden. All righty, good stuff. Y'all, I love y'all so much. I'm going to head out here. We did the longest podcast of the year. Can I get a whoop whoop? That's what I'm talking about. Almost an hour and a half. I hope this was beneficial for you as you prepare. Hey, be blessed, y'all. Love y'all. Miss y'all more than you know. If you need help, 7:30 to 8:30 Monday morning. Actually, it probably won't be till 8:30. It'll probably be from like 7:30 to 8:10 because I got to head over to the exam there. But if you need some help, come on over and we'll rock and roll there. Actually, even shoot me a message beforehand, and that way we're all on the same page. All right. See y'all. Be blessed. Have a good one. Bye.